So, good afternoon. Fancy doing this on a Monday afternoon? Didn't see this coming. So, if you're going to be watching this afternoon, please make sure you say hello in the chat. Make sure you like the video and subscribe to the channel because there are more content coming up in the very near future. I'll explain a little bit more about that as we go. So, the purpose of today's live stream is to have a chat with some guys from Airfix and the people that Airfix work with. Now, as you can see from behind me, the 124th Supermarine Spitfire Mkivc is out in the shops, a cracking kit, and we're going to talk about that mainly this afternoon. So if you've got any questions, we've got a couple of guests that I'll introduce in a second. We have got a slight change to the schedule, but you know, these things happen. But yeah, we'll explain as we go. So if you've got any questions, pop a question into the chat, but make sure put a nice big Q right at the beginning so I don't miss it. As long as it's appropriate, nothing silly, please. We don't do that on here. So yeah, any genuine questions you have about the process of making models, today is your day to get involved. So let's get our guests in. I'm going to go by alphabetical order. My guests didn't know I'm going to do that. But anyway, the first person that's going to be joining us today is this young man here. This is Chris. Hi, Chris.
Hi, James. How you doing?
I'm very well. So Chris is one of the designers from Airfix. And you might all be thinking that watching this thinking, well, funny, I thought it was Luke. Well, yeah, Luke's thrown a sickie, unfortunately. Yeah. And Chris has been grateful to jump in and help us out today. So, which is good because we can pick his brains about all the way in which we design our models and stuff. Or Airfix does anyway. We don't. We just make them. And our next guest is Mark.
Good afternoon.
How you doing, mate?
All good, James. All good. Hi, Chris.
Hi, Mark.
Hi.
So Mark is the young man that's involved in the production of the kits. Works for a company called Plastech. Got that right?
Yeah, Plastech, based in New Haven. Been working with Airfix for a number of years, mainly in the quick build product range. We did do a few glue kits with the guys a couple of years ago, but obviously we have to be commercially aware of what we can do in the UK. And obviously the Mark 9 Spitfire was a great opportunity to work with the guys at Airfix again and get this kit where it should be back home here in the UK. And we're proud to be the manufacturers of it.
Rightly so too. One thing I should do really, Chris, tell us a little bit about yourself.
Sure, of course. Yeah, so I'm one of the designers at Airfix down in Margate. I moved here 10 years ago for the job, which has the, fortunately, is pleasantly by the seaside, which is a nice place to live. But yeah, I got given the briefing to do the Mark 9 Spitfire just I guess a few months before lockdown started, so it was mostly for me a project that I did working from home, a bit novel. Turns out I'm not cut out for working from home. I need to not have distractions of things to do in the garden around me. But the Spitfire was a lovely project to be doing from home, nevertheless. But it was great to get back to the office and before it was finished and to run it all past some of the other guys, and especially with Luke being around. To tell me off all the things I got wrong and make sure that we'd fix them before it had gone into production. So yeah, it should be good. I'm looking forward to being here today. So unfortunately, Luke is feeling a bit unwell. He's the one who has all the knowledge, but hopefully I won't be too bad a substitute.
He's the rivet counter of the team. So he likes to be known. Sorry for my ignorance as I was doing that. I was just answering a message in relation to the fact you'd stood in. So yeah. So anyway, I won't say any more about that because that might go ping quite a few times. We'll see. But anyway, let me see. So I'm going to have a quick look to see who is with us in the chat. There's 11 people with us, which is more than I expected at this time of on a Monday afternoon. So I'm just going to read through very, very quickly. I probably won't do this again during our chat because we are limited on time with our guests. So Stuart Bremer's is saying good afternoon. Good afternoon, Stuart. Darkosaurus says good morning, good afternoon. Dominic He's saying hi to James. That's me. Hiya. Ian Douthwaite's with us as well. Great modeler. You need to get him involved. He's a brilliant scratch builder of trucks. So if you ever need any advice for trucks and stuff, he's the man. Just set you up here. Sorry about that. And yes, we've also got Mark Schiller saying good afternoon, everyone. Indeed. So, like I said, if you want to ask any questions, pop it in the chat. Put a Q at the beginning of it, and we'll get to that as we go. So, I'm going to let them warm up a little bit because the people we did go a little early, not a lot, but a little early, and people generally stroll in. Don't want to be the first at the party, do you? So let's talk to Mark for a second about the manufacturing of this kit. I mean, obviously, I'm guessing from your passion that you show through the product that you make. I mean, obviously that's your work, but yes. I believe there's a bit more to that passion. You're a model maker, right?
Yeah, as you know, as I was saying, obviously just before we went on air, I'm a child of the 70s, and as we all know, you know, back in the day, you know, we didn't have the internet, we didn't have social media, there wasn't phones, and on a rainy Sunday afternoon, I was giving my grandfather a Matchbox kit, a Porsche 917 race car, and said, "Here we are, have a go at that." And after cutting myself several times with a Stanley knife and, you know, getting glue everywhere, he sat down with me and said, "Look, here we are, let's do something proper together." And it sort of lit a spark with me, you know, that you know, I'd always played with Lego previously, and I was probably about 8 or 9 years old, and he worked in manufacturing as well, and he had quite a high end job that was a bit stressful, and he'd come home and his way of escaping was model making, and it's sort of something that's always stuck with me. And you know, as I've grown up, it's been making models. I got obsessed with making 1/24th Tamiya models. You know, mainly as you see behind me, I've got a passion for race cars, especially Group C. Back in the days, always at Le Mans. And, you know, to go and watch the cars, then come home and build the models, used to be something that used to get me quite excited. And it's been a passion for me, model making, and it's something that I got across to the guys a few years ago at Airfix when I knocked on the doors. Obviously, having worked in the plastics industry, not particularly, you know, around toys or models. It was mainly in building products such as pipe work, and it was around, you know, soap dispensers and things like that. But I thought, well, the knowledge of tooling, the knowledge of molding, I'd like to put it into something which I actually, you know, combine a bit of work and pleasure, you know, aircraft kits and cars and things like that. So I spoke to the guys at Airfix, and at the time the design director there said, "You're getting on my nerves, leave me alone." He said, "Come on," you know, and in the end I managed to get an appointment with him, sat down with him, showed him what we could do and offer as a company. And we never really looked back. That was in 2012. So the quick build range, I think we've done 26 products now in that line, and this is now our 7th in the glue kit range. I say, you know, we dropped out of the glue kits about 2 or 3 years ago purely on the commercial reasons, not for technical reasons. Obviously, they have to be viable, and obviously now with a 24 scale kit, obviously a higher end product. Yes, you know, we aren't as cheap as offshore manufacturing options, but it's at a point where those you know, a few pounds difference, you know, the kit can carry, you know, that little extra, you know, cost, and obviously, hopefully, the kit will speak for itself in terms of its quality, not just in the tooling, but obviously in the molding and the processing side, and even down to the material. Like I was saying earlier, the material is a formulation that we managed to revive from 1985 by talking to one of the previous material suppliers and saying, you know, this is what we made it in the 80s. You know, we managed to bring that back on board.
Excellent. So, Chris, are you a model maker yourself, or is it just work?
Yeah, I'd like to say that I am. It's certainly, I guess, all chaps can probably relate to it. In my childhood, it is something that I used to do. Definitely, I think it's the thing that got me into product design, along with things like Lego and Meccano, and for me, what's it called? Connects was something that I used to play a lot with actually as a kid. And model making Airfix kits were definitely a part of that kind of grew my desire to like learn how to make stuff and build things. But I can't say that I do it at home anymore. So now it's mostly a thing at work. I think I find myself needing to do something that isn't quite so like fiddly and technical in the evenings or the weekends. Like all day long, it's lots of very small little movements on the mouse or like building up little kits at the desk, which is great. But so I for a little while I had a little side weekend job making sheds for friends and things like that, which certainly a different level of I still get to make stuff. That's the thing that I love doing, but getting to hit things with a hammer instead of really finely trying to put something in with a pair of tweezers. Just needed that break from the looking at something really small for a bit. So no, I can't say that I do, but I have very thankful the last few years when Paramjit has joined us. I'm sure most of the people here will have met or seen Paramjit. He's done a lot of the TV stuff that we've been putting out. But he is a very keen modeler and I personally think an excellent modeler. And so while he's been there only a few years, actually probably 4 years now, time flies. But I've been learning loads from him. I'd like to think that he's learned something from me, but I've probably learned more from him in the short time. Yeah. And now I regularly asking him from his kind of like modeling perspective, stuff that his experience, like, oh, how would you like these parts to be split? These are a couple of ways that I can see it working, and I can imagine that it could be tooled and like physically go together. But from your side as a painter and as a model maker, what would you prefer? So I'm learning stuff. Obviously, we're all learning all the time, but I've been on quite a journey the last few years, having good chats with him, hopefully filling in the gaps that I haven't brought myself.
Yeah, it's strange, isn't it? I can honestly imagine from the work you do and the way you put things together in your mind. I mean, it actually links quite well to a script. I'm going to throw a slide up at you.
Great.
So, so this is a part of the presentation you gave us a few weeks ago. Now, obviously, these are all numbers, but this is your thing. This is what you love, isn't it?
Yeah. This was something when I first came to the company. Was presented with one of these, and I thought, "What on earth are you showing me? How can I make anything from this?" And after a chat with Matt, who's been here a bit longer than me, helped me decipher it, and I've sort of begun to like really appreciate them. And as you're flicking through books or going through old engineering drawings, if you come across one of these offset tables, it's like the holy grail of shape reference, rather than, because you can never really trust any, especially GA drawings, even from the original manufacturers. Like they're probably a good starting place, but they're not always totally spot on. Whereas something like this is the like what they've used to engineer the real thing from. So all this, a set of numbers, essentially a big plot of coordinates for every station along the aircraft, from sort of right from the front to the end. They're also often broken up. So this is probably, I think, the fuselage section we're looking at now. Certainly the cross-sectional drawing, you can see these different stations layered on top of each other. And then you have a separate one for the wings and maybe a separate one for the tailplane. But from that, as you, I think I said it before, it's like a professional dot to dot. Once you've plotted it all out, you can just draw the lines and you suddenly have an aircraft. But I quite enjoy. I think the thing that I've learned that I work quite well with as I've tried different jobs and then with like the little bit of shed building is imagining in my mind how stuff's going to go together. It's the thing that I'll will drift off to sleep doing. Is it sort of stops me from thinking about all the other stresses of life, and I just write, how on earth am I going to make these two bits work? And I can just go to sleep thinking about that, and I'm a very happy boy. Yes, it's a nice job for that sort of thing.
Yeah, indeed. I mean, I won't go too mad on the slides, but I'm guessing these were sort of original drawings as such, and that's what you referred to earlier. So it's a case of meshing all this information together in a way which you can then put it onto a screen for you to do what you do.
Yeah, absolutely. So with those the offset tables saw before, they'll give you the basic kind of really simple shape data, and then you find drawings like this which help you plot out where like it's a bit of a quicker way to see where the ribs are and different bits of lines and panel details you can get from this. I guess it's a series of stages. You start with the simplest, most generic sort of overall data, and then you start finding the more specific details, and layer after layer, you begin to add all of that information to it. Depending on the project, and now obviously we do a lot more 3D scanning, which it sort of replaced the need for those offset tables. It gets you to the same point, that kind of basic general shape, quite quickly. But on a project like this, we had all the original drawings anyway, because we've done loads of Spitfires, and there's a lot of like crossovers. As long as you got good research and you know how the sequences, like the different variations, were built on each other, so you could use some of the Mark V drawings, because you know most of the Mark 9 is a Mark V, but as long as you know where it changes, then you're safe. So for this one, we did use some of that data instead of using a scan. But yeah, one of the challenges with getting the original manufacturing drawings is that you can start off with like 30,000 drawings, but actually only 100 of them will be particularly useful, because a load of them will be little brackets and something that's far too small to be of any use in a scale model. So I know a few years ago when I did got to work on the B17 project, we had all the original drawings for that. I spent probably about 2 weeks flicking through them all, trying to find the useful ones, and trying desperately not to let my mind switch off. You know, when sometimes maybe reading a book or something and you get halfway down the page, you suddenly realize I haven't read any of that. Well, this would be happening, or like 15 minutes ago by, like, I literally don't know what the last sort of 100 pictures I just looked at were. I need to now go back over it and really try and focus. So it's different projects has different like sources of information. I guess that's something that makes it quite nice and interesting. Like sometimes you have so much information like that, and it's a challenge to decipher which is the useful bits. Other projects, it's a nightmare to find anything. So anything you come across is like, oh, fantastic, I'll make sure I'll keep hold of that. Which makes it all a little bit interesting.
Cool. Well, we're going to come back to the design bit in a minute or two. I just wanted to ask Mark a question. So with the manufacturing, I mean, obviously the tooling is being done overseas, and then you get the tooling. What happens from that point onwards for you?
Well, our journey starts a little bit earlier, because obviously I work in conjunction with Chris. Once we're confirmed that we are the appointed manufacturer, there's several things that need to happen. So the first thing to happen is obviously the layout of the components. So Chris obviously has an awareness of obviously what the components are that are required obviously in the kits, and there's 433. Correct me if I'm wrong, Chris, in this particular one. Now, those are obviously, from laying those out, when you look at a tool frame, there's your sprue, there's your frame. Now you want to put the relevant parts in the relevant places. So obviously that's a panel set you've got there. So obviously we've got wing parts, we've got various other components in there. So it's as we're managing the build, you try and keep the parts balanced. So ideally, Airfix kits and as with all model kits are quite unique in their approach, because what you've got is quite, if you look at the mass of that part there, that's probably 50 times greater than the mass of that component there, or 100 times if you take that tiny little part there. So you've got to try and fill those and try and balance those. So what we're trying to do is try and keep the right parts on the right tool frames, but at the same time, what is viable in terms of actually producing that through an injection molding process. So Chris will go to, obviously, we'll work with a Chinese partner, and we'll try and put what we feel is the right parts on the right sprues, but then we'll try and look at how does that actually work in reality to actually balance those parts. Can we produce those parts, fill those parts? Then we'll also look at the tool layout. So we're working in conjunction with Chris, and Chris will throw us back a layout, and then we'll say, right, that tool is of that size, so we'll try and appropriate that to the correct size injection molding machine, because injection molding machines, as you probably know, work in a clamping tonnage. So we'll make a mold that's closed. It'll be in two parts, a fixed half and a moving half, that will open and close and obviously produce the parts, as you've probably seen on other videos. So what we'll do is we'll work in conjunction with the Chinese, but we want to make sure that the tooling is correct in terms of how it performs, because you can't have it getting too hot. So we have to put a water system in, we have to put an ejection system in. The modelers hate, we all know, ejector pins. They're a necessary evil, and modelers go, why has it got an ejector pin in that place? Why can't we put it in? very simply, you know, I'll give you a good example. The wing spar in the new Spitfire there, as you will see, has actually got these little overfill points to try and put the pins, you know, where we need the force to eject it. So in other words, if we can't get the force where we want to on the component, we'll put these little overspills in. These actually help to fill it as well, but they are there purely to actually push the part out of the tool. So we're trying to make all this a consideration before we've actually even made a tool. We'll look at, you know, the drawings of the tool, the parts on those, the number of tools that are actually involved in this. Because again, there is a commercial aspect to this, and I think, correct me if I'm wrong, Chris, I think we've got 4 frames on one tool, so we've got a really big mold going on, but it's got 4 frames in it. I think HJ and K are all on the same tool, so you're producing those. So it's coming up with what works in tooling, what works in injection molding, what works through design, what works by having the pins there. So all these factors before we actually make anything are all taken into consideration. So there's many months of work before we actually start cutting any metal with our Chinese partners. And I've got to say they are a master at what they do. You know, it's supported by us here in the UK. So we're looking for the best things to go into the tool. We've got the correct alignment, we've got the right water systems, the pins are in the right place. So we have a design brief in terms of how we want the tools and how it works with the components. But you know, when it comes to, you know, to detail, you know, I mean, beautiful. Like you've probably seen the EDM work, you know, the surface detail, the rivets, the panel lines, absolutely just a work of art. And to tool that, you know, it's masterful. And obviously with modern CNC equipment, and again, I was talking about this with a friend the other day. I was about Airfix, the original Airfix tools were more pattern made. So where you make a wooden plug, and you know, you didn't have the modern CNC, and it relied on the skill of the tool maker or the pattern maker to produce those. So originally tools were made, and yeah, if you took things in scale, they were very slightly out of scale. They were, some planes were, you know, I think it was the original Spitfire. If you took it up in scale to the original 172nd, it was about 3 inches longer than the original aircraft. You know, there were these inaccuracies, but what the guys are doing at Airfix now, what people like Chris are doing now is taking those original drawings and building in the accuracy of the components. But that comes with its own challenges, like we spoke earlier about sections. You know, that's a good sprue to look at there, the fuselage section, because that fuselage section there has got some very thin wall thicknesses in it to try and fill. So it's correct to the aircraft, it's correct to the component, and we're getting across a very accurate representation of what the real aircraft was like. But it has its own technical challenges, it has its own difficulties as an injection molding, actually trying to produce that component. So a great deal of testing goes on. You know, and again, before we even make the tools, we run a program called MoldFlow. It's a computer fluid dynamics program where we create a virtual tool. We'll actually look at where we're going to inject the parts, where we're going to fill it. You know, the number of gates on the part. I've seen that on comments online as well. Like, oh, why has this one got so many fill points in it? It's got so many gates. I have to trim it. Well, yeah, purely because it needs that level of flow so it can get, you know, into those areas. And you know, to get there again on early one, it's hard to see on the camera. There's some ghosting. So we call it ghosting. There's some areas there where the plastic is struggling to fill through the section. I'm trying to get it on the screen. Yeah, trying to fill through that section. So we'd have played with the gating. We'd have opened up the gates. We'd have opened up the runner. I always say it's like trying to fill Wembley Stadium through a loft hatch. You know, that's your injection point. And this is a road system. It's a road network, and it's determining the traffic, the volume of material that's making it into these areas. And particularly, you know, one of the other videos that you would have seen online, if it's in the other ones, it's been a big issue getting the pack on there. So we can fill it. We can actually get the moulding to fill in this area, but you're getting some wobbly bits, some distortion here, because once we've actually filled it, we're actually having to put a pressure on to actually keep that. And actually, so we don't want any sink marks. We don't want any visible sink marks. So it's striking that balance. And these are things that the mold flow analysis before we actually make the mold gives us that information. It sort of tells us what we already think we already know. It's a bit of added insurance, but it allows in the design process to get that right in the tooling. So when we produce the tools, when we make the tools, I always say, like, making the tools like making a race car. You won't ever turn up at the first race and expect to win. You have to go through a series of testing, development, and what you thought may work isn't always the answer. So we need to increase the amount of flow. We need to, because we can't change the material. The material is the formulation of the material. It has a viscosity at a certain temperature, so when it melts. So we'll play with things. And again, some of the molds run slightly hotter than what we would like. So we're having to introduce a bit of temperature in there to keep the material flowing and moving through, certainly where we've got thin sections. And obviously with styrene doesn't like thin sections. I mean, it's almost a perfect storm. So you've got very thin wall sections to give you accuracy of kit, but in the same breath, the material, the styrene, doesn't necessarily like flowing through very thin wall sections.
So you were talking very briefly there about, excuse me while I fiddle and clunk some buttons. You were talking about the design process in relation to detail. So this is a slide that you showed us about part progression. So once you've got you're designing the part in CAD, I'll let you're going to explain it so much better than I can, Chris.
Sure. Yeah, so these are some snapshots I took actually after I'd finished the part. I sort of rolled the thing back to find sort of what felt like the most interesting stages of seeing how it would build up. So as you hopefully follow it from the arrows, the top left is showing how we start. We start with something we call the skeleton model, which it kind of carries all of the basic information we want across the whole kit. So every part will then be referenced back to the skeleton model. The idea being that if we change something, it will update all the parts that are in relation to it. So rather than having to if I move a sort of a break between two parts off by 1 millimeter, I don't have to do that twice. I just do it once in the skeleton model, and hopefully, if everything's working, when it regenerates, that change will have happened in every part that it's referenced to. So in the top left, you see the skeleton model, and then that's gone down into the part where I've taken across some of the information into a new file, and starting to split it up and cut it into how that part will be. And the one below it, I've made it into a solid. So I don't know if anybody watching is a CAD technician, but we have you kind of often start, for our sort of thing anyway, start in quilts, which everything doesn't have any mass to it. It's just a impossibly thin imaginary surface in a way, as far as the computer's aware. But then at some point we need to solidify it, and that bottom left one where the colors change is now it has some mass. And then sorry, oh no,
that's okay. Yeah.
I think I also heard my own echo, which confused me. Answering myself. Down the middle, we started to refine that part a little bit more, cut out other little areas we need, and then starting to add some of the bigger rivet detail. So these are some of the Zeus fasteners that hold the cowling on. And then the one below that is a bunch of the rivets. You can see all these really long extrudes that are going through, which are presenting where all the rivets are. We've had to sort of draw all of those out individually in one extrude, which is why some of this can take quite a while. There are ways to pattern, but because these rivets aren't always that uniformly done, you still end up needing to at least mark them out in some way. Even if you can then copy the extrude, you've still had to for majority pinpoint where they are, because they're not always equally spaced. And then you see on the far right, just some more of that detail being added, some more of the panel lines and little hatches to really give that part some of its character. It's a really nice part of a project to do. Sometimes I want to jump ahead to adding panel lines and rivets earlier than I should do, just because it makes the thing come alive. It gives it its own character. It gives me a real sense of its scale. But if you jump to that too early, and then you suddenly realize I need to adjust something, I haven't quite got something in the right place, all of this data that you've added on over the top can go wrong. So I really often need to be patient and not jump ahead too soon, because if you do, you end up you're kind of building a tower, and if you've not built it well and you want to change something in the foundations, then the rest of the tower can collapse and you've got to spend an afternoon fixing it all. Not that ever happens, because we're much better than that. Of course not. To go for a little walk and internalize the scream. But often we get there, and it's quite an enjoyable process at the end. But as Mark was saying, the kind of challenge of the things that we're making, we're not making them to be ideally injection molded. Unfortunately, that's not if you were to make something that would be perfect for injection molding, you wouldn't be making a scale model of a kit, because they are or at least not an accurate one. Anyway, you could, you're really having to you're stepping on this boundary, the line between something like being a good, accurate representation and something actually being physically moldable. And unfortunately for Mark, we are often more on the physically accurate.
I think, like you're saying, there's because obviously there's always a dialogue between ourselves and Chris is coming back and saying, yeah, see where you're at here, but this isn't going to work exactly as we want it to. And so in some areas, give you a good example is, one of the things that we picked up on, and again, you can't change it, is we've gated it here. So we've got a nice fill point here. So the plastic's coming in. What we could have done is we've got a rib. So we've got a series of ribs here. If we'd have flowed it into the rib rather than the thinner section, we'd probably done ourselves a bit more of a favour, because it actually works as a flow leader. It actually works as a, if we put it through that section, it's actually a better, we're actually got a thicker section there where we could have fed into. So there's little bits and pieces like that. So every time you tool something, every time you look at it, you think, God, we missed an opportunity there. Yeah, we could have done that differently. But, we should have changed it. I've just going back to this sprue. I've just grabbed this sprue. I've just it on there. There we are, 130. This is an original test sprue from China. So 136.9 grams. And again, what we're doing there is we're optimizing the shot weight to see what is the most material we can put in there that we can fill with that doesn't flash. Because if we try and put too much material in, like you'll note on that wing section there, we'll actually start to blow the tool. Yeah, that's a good example of thin section there, where the wheel wells are. You can see, and again, that's a test material. This is a shot that we did here in the UK. You can see testing the colorant, even down to the dispersion. So we've got high density grey areas there. This is the first test material we used. And look, we've actually got a short, got shorts on the end there. So this is just a development sprue. So we're putting pressure in, trying to fill it. We're actually blowing the tool. So we're actually forcing the plastic. That's good. That was in a machine that had 610 tons of clamp force, and we're actually able to blow those tool faces apart using the pressure that we're actually using to get that to fill before we're actually filling everything else. Incredible, yeah. And it's these are things that happen. And so we will go backwards and forwards again. A development program, a part of the development program, we're testing China. So the first off shots will come from China. So after the SLA process, we'll have some stereolithography model mades or some very nice prototype model mades that Chris have put together, showing how it all fits together. We'll get the test shots back from China. We will get the test shots. Chris will get the test shots, and then we can actually see, in reality, how do these bits actually fit together? Is there any problems? Are there, again, things like we saw in some of the early test shots, ejector pin stressing. In other words, where the parts are gripping in the mold so much, the pins are actually deforming the surfaces, trying to push them out the tool. And again, all these things are corrected and looked at. And again, before it reaches production, yes, we'll test it in China, but we'll bring the tools back here to the UK, and the tools are with us for quite a few weeks. Everyone's like, we're waiting for this tool. We're really desperate for this model. When's it going to be in the shops? When can we buy it? Well, really, guys, we want to give it to you as soon as we can, but we want to give you something that's right and has worked. And just because we've made it, there's lots of little tweaks, and it's hours and hours and hours of tweaking just to get this as good as possible.
So what do you think is between the two of you, what do you think the biggest hurdle is that you have to overcome from the design of the sprues and the parts and that sort of thing? Is there a particular obviously the flow, I understand that, and making sure you can get it the density right, etc. But is there anything that's like the one big thing that will always go
Well, it's probably a different answer for both of us, but for me, it's trying to strike the balance on having large part, small part on the same sprue. Now, I'll give you a good example of that. Is if you look at a lot of the Japanese manufacturers, that they will tool to optimize the components on that sprue. So and they will produce. Give you an example, on a 1/24 scale kit, you may end up with 3 or 4 sprues. But if you look at Fujimi, for example, I've got one. How many sprues are there in there? There's loads of sprues in there, because there's lots and lots of tools. Because in their marketplace, they know they're going to sell hundreds of thousands, particularly of a particular model type. So they will almost make a development tool to optimize what is the best way that we can make this component. And I'm not saying we compromise with Airfix. We have to be realistic. It's a commercial project. It's got to be viable. Yeah. How many kits are we going to sell? How can we tool this the most economic way to actually make it get off the ground, so to speak? But at the same point, what can we deliver? And it is quite challenging when you've got, the wing spar. Again, I'll come back to that. that's a lovely piece of tooling. We've got the wing, so we've got a large wing, lower section wing, 2 stop wings. Then we've got this wing spar that's here, and again, in an ideal world, we'd have that wing spar on a separate piece of tooling because we can do a lot more with it and control it a lot more than we can the wings. In reality, it's not commercially viable to go to the cost of a completely separate tool to have that. So what we end up doing is we end up developing it, and there's lots of complicated shut-off areas, and there's lots of things that are challenges. And again, none of it's insurmountable, but it's just lots and lots of work. And an example is we had it this morning. So what you've got is you've got a mold that's made with lots of complex, we call them shut-offs. So areas of steel that come together to stop plastic escaping. If it escapes, you get flash. Now what happens is those tools are opening and closing thousands of times now, producing these parts. And what's actually happening is tiny little, it's collapsing. If you imagine you've got, on a tool face of that size, if you look at, there's a beautiful example. Look at all those shut-off areas. Everywhere there's shut-off in there. So you've got the guns, you've got obviously wing spar parts, you've got little clips, little fittings, all these bits going on. It's very, very complex little shut-offs. And where we're opening and closing the tool under tons of pressure, we're just starting to see the edges just move a little bit, almost microns, and it starts to grip. So we're in there with a little diamond file, some very, very fine stones, just taking those edges off, because what we want the parts to do is release cleanly from the mold. So as soon as the mold opens, it can eject off. If you've got a tiny little burr and it's gripping, the moldings are sticking in there, and it's something that's continuous throughout the run of the tooling. As it's opening and closing, it's bedding off, it's shutting down harder and harder and harder. And it's not poor tool making. It's just what tool making is. These are what the molds
part of the process. Yeah,
it's all part of the process. And again, my guys that are on the machine are continually looking. Always. It's all about, as you saw obviously when you came, James. It's all about the quality. And repeatability. And yes, we'll test the mold in China. Yeah, we'll make a few hundred test parts in China. But when we're making 10,000, it's a different animal. It's a very different beast.
Absolutely. How about yourself, Chris? Is there any one thing that sort of jumps out at you during the process that sort of?
I think I kind of related, actually, really similar to that last thing Mark was talking about. That's from the design point of view and trying to get it to be moldable. The most frustrating thing for us is adding draft often, which is the kind of just like tilting straight edges up by a couple of degrees to try and help them fall out of a tool. But what you think should be a very small little change in when you're like zoomed in on CAD can make a part suddenly look nothing like what it should do, and a straight edge suddenly becomes a weirdly off at an angle edge, and the whole thing looks wrong. And so trying to imagine ways to add draft without it affecting the final look of the thing is just frustrating. You're like, if only like some magic could happen, and they didn't need it. But and then obviously the more draft you add, the better it will come out of the tool. And so there's this little balance of how much can I add that it doesn't ruin the look of this thing that should be straight, but I can't do it straight because I need to add a little bit of this to it, and sort of often at the boundary, and sometimes we've underestimated. Well, probably most of the time, if it's anything, we'll have underestimated, because we're never going to go over more than I want to do. And there's this sort of quite expensive learning curve that we only really find out when it's worked after you spent a few thousand, tens of thousands of pounds on a mold. You're like, bugger, could have done that better. But hopefully next time we'll do it a little bit differently. And as we're always wanting to try and improve the quality of these of what we're doing and sort of make stuff even finer, you're still having to learn each time. You're like, okay, may have pushed that bit a little bit too far. The other thing that Mark was chatting about then, which it's been an interesting process over the last few years when we're doing these big models, of trying to kind of group parts to make as an enjoyable building experience as possible, so that all the engine bits are on one frame. And it's sort of it felt like it's come out okay, but it's been really useful having conversations with Mark and it being tooled in the UK and being able to have more direct chat about it and seeing the challenges that have then arisen because of wanting to make something a more enjoyable sort of user experience has made a more complicated manufacturing experience. And actually maybe that isn't the best route for us to be focusing purely on. And so that's been a good conversation, and these little, like I would say, always wanting to learn, always wanting to improve, and while we'll sort of still try to make it as enjoyable, especially the big kits, you don't want to be hunting around like 5 different frames to build one small thing, but actually maybe we can compromise a little bit in the middle. So that's been a useful, like, yeah, we're definitely learning.
So you were talking about, sorry, Mike, I was just going to jump in there a second. You were talking about making small changes, and how that does. I mean, I know one of the things in which has really impressed me with this particular kit is the surface detail of the wings, the panels, and you know, even down to the texture of the seat, for example. I mean, how difficult is that to recreate in CAD?
Well, what's interesting with the seat is I initially did it wrong, because quite a lot of the you see quite a lot of restored versions of the seat having this kind of fan pattern around the top, which turns out wasn't original for the Mark 9 that we were doing. So that was one complication. I was like, just copy the thing that I had a picture of, and turns out, no, there's multiple different types of Spitfire seat. Who knew? Well, I do now. But
who pulled you up on it? I've got to ask.
Yeah, but do I have to change it? So yeah, so any sort of, to be honest, doing fabric effect and the sort of stress skin effect that we've started to do now is probably the most is the hardest thing to do in the CAD software that we use, because the software we have is very much kind of designed for manufacturing, and it's often quite straight, solid shapes. It's not really been designed to create soft textures very well at all. Very different to the kind of software that you'd use for like filmmaking or stuff like that, which is much better at creating fabric and textures, whereas this really isn't made for that. And so creating things like that seat are quite slow process. You have to like split each little panel up and remove what was the flat surface, take that away, add some lines that will be the kind of the waviness, and then create a new surface using that wavy line as a reference, and it kind of helps to try and add that in, and you have to do that each time. And then they got the little challenge of you kind of need to overdo it in the CAD, and it looks too much in the CAD, because then when it comes in scale, it looks about right. But that can always be a little bit nerve-wracking, especially on this sort of textured surface stuff. You're like, I don't want it to look over the top because it would just look silly. Like, this is supposed to be metal, not made out of cotton. But if you do it too shallow, then it doesn't appear at all, and all of that work you've done is utterly wasted. And so that balance is always feels like a little bit of a risk, or like, oh, I think this will be all right. I think we're getting better at doing it, because we've got past examples. We can look at a few kits you've done before, and like, okay, you raise that surface off by like 1/100 of a mil, and it looked a bit like that, so maybe that looks okay. But when you're doing with those fine sort of tolerances like that, sometimes it just does get like cut a little bit deeper into the mold than you've asked, and so you're kind of it's always like when you've added loads of detail like that, the only time you really know how it's actually going to come out is when you get your first set of shots through, and that's just like nerve-wracking. Often you're like, oh, is it going to be okay? And yeah, sometimes, most of the time it's great, and then sometimes you're like, oh, I kind of need you to do that again, and hopefully we can only really then like take a little bit of material away and make those surfaces a little bit deeper, because you can add metal back on to such a large area like that.
No, that's always the issue, and it is, you're always working in, trying to gauge everything from metal, what we call metal off condition. Metal on in tools is a big issue, and it can be done, it can be welded. I mean, there's a couple of areas you probably on a couple of the ailerons where there's been some minor adjustments been made through weld, but typically what we'll always try and do is work in a metal safe condition, so that produce it without the surface finishes to actually make sure it works, and then you come back and add the texture. And I mean, a totally different kit, but like the quick build camper, for example, the split screen camper van, the fabric roof on that, I mean, that's just beautiful. To get that, and you've got a ribbed wave. It's a very organic wavy roof, but yet it's got the fabric lines on it. And that was all for an EDM process, for a spark erosion process, actually burning the surface, the detail into the surface, and it looks like a piece of fabric. It's a piece of plastic, but it looks like fabric, and that's a real skill to achieve.
Yeah, amazing. So what I'm going to do, I'm conscious of the fact that we've been busy chatting away, got loads of stuff said about, but there has been a couple of questions. Now, I have in a way, sort of an apology for anyone that asked the question, because obviously these guys will only answer what they know. And if it's commercially sensitive, you're not going to get an answer. That's why I say careful with your questions. I've got a couple, and I most certainly won't set them up. But one of the questions in the chat, which we can talk about maybe, because I'm sure you're not going to be able to answer it in full. The question is, in the 24th range, Airfix previously did a 109, a 190, a Hurricane, a Mustang, etc. Will these kits be revisited or modernised? That's from Stuart. Now, obviously, I can't ask you that as to give us a scoop, guys, because you're not going to tell me. I know that, but from a design part, from your position as a designer and your position as the manufacturer, do you think, given the previous kits we've had from Airfix, do you think these need to be revisited? And do you think that in an ideal world, maybe so it's something that maybe in the ether, or maybe not in the ether, ether's the wrong word, in conversation, I think would be the right place, because obviously you guys at Airfix, you're 2-3 years from what we're getting right now. You're 2-3 years down the road for what we're going to get next. So
that's great. Very valid questions. I mean, so I think certainly something we look back at and see what stuff we've done before and what's sold well and what we could redo. I haven't heard any murmurings of us like actually going back to those toolings for like the next 24 scale stuff, but those subjects certainly have been in the conversation. I think they're all quite they're not they're logical choices for us to look at next, aren't they? So it doesn't feel like a crazy thing to say, yeah, of course those are things that we've been chatting about.
109.
Excellent.
Don't get excited, it just happens to be in my office.
What are you doing, Mark?
So I mean, obviously one of the questions that's asked quite often is, why do we need another Spitfire? Well, commercially, it's just the most sensible thing to build because it's such a popular and iconic aircraft, and like you say, those suggestions that have been made by Stuart there are logical in a way choices commercially.
The other little thing in there for us with this scale is, I guess we generally felt a little bit, we don't want to oversaturate it with these big expensive models because we want you to buy the new one that we've done, to be like just very, very like maybe that's not not the answer you want, but it is just commercially sensible, isn't it? We kind of want there to be want to make sure we sell enough of this new one to get the money back on what we've invested into it, because if we don't do that, then the company might not let us do another one. So hint hint. But
I think that's the key there. It unfortunately, obviously, if you ask any modeler what do they want a model of, the models that I want will be very different to the model that somebody else wants. Everybody's got their favourites, and that'd be great for this, and this would work great for, which is fine. But it's what Airfix are trying to do is they're trying to hit effectively, it's a mass audience. You've got to have something, like Chris already said, there's something that's commercially viable. So if you look at the project, the tooling costs and what the model cost itself, yes, it is an expensive event. It's not a it's a luxury item. It's not an essential. You don't need to have a Spitfire, and you are spending the best part of £100 on a kit. Now, yes, people go, it's a piece of plastic, it's a cardboard box, but the amount of development that goes into it, the amount of tooling that goes into it, the amount of time, is what you see. The kit itself is just the tip of the iceberg. So to make these things happen, yes, this money would have been set aside 2 or 3 years ago now, obviously, and again it's a long time of a designer sitting there before it even gets to a single shop on itself. There's a huge amount of time and effort gone in, and again in kit selection, I'd like to be doing a lot more 124 products. So there's a lot of things that I'd like to be doing. I like racing cars. And if somebody said to me, "What kit do you want to do?" I want to make a 1/8 scale, Porsche 956, or I want to make a silk cut Jaguar 112. These are things that I want to do. But is there enough of me's out there that are going to go and spend £100-150 on a kit to recoup the level of investment?
That's a very valid thing. At the end of the day, I think we as model makers, I feel anyway, I think we're very, very spoiled. We've got such a multitude of kits, such a multitude of manufacturers. Don't get me wrong, I do suffer from the same thing every other modeler does, where another 109, another Tiger. Don't get me wrong, I understand the reason for it, but the other one thing in which I have noticed over the last few years, in fairness, is that everyone seems to be stepping up their game. So 4 or 5 years ago, you buy a Tiger tank, let's say, from an X, and now what's coming out, it's just like, wow, mind-blowing, better detail. I mean, it's marginal, don't get me wrong, for the person that might not realize, but for a model maker, some of the kits are just coming out, you're just like, oh no, how did they do that? And I think the 124 Spitfire is a really good example of that. Is that I was, funny enough, there is a video that we're going out soon, which I won't tell you about right now, but it just so happens I have the 124th new Spitfire behind me here, but I also have one of your older ones. So I got pulled out the instructions. Now, I've got the instructions here of the new kit, and I can tell you it's 244 steps. Now, I've not done my research. I don't know how many parts there is, but I can tell you on the old kit, it's 33.
Yeah.
Now, don't get me wrong. I think a lot of it, although I've not looked 100%, but I think a lot of it is that they've broken down the parts. So you're concentrating on parts rather than a step having several things to do. That's part of it, but it's not the whole story by any means, shape or form. And just looking at the sprues, you can tell. I was going to play a trick on Dale actually, and put all the sprues from the other box into the new box. I think you've put the wrong ones, Dale, but I didn't. But yeah, I mean, there's remarkable differences in it, and I've not done my research before this to tell you exactly the date of that particular kit. It's a Mark 5, the Mark 5B, so it's a different mark anyway, but it is vastly different. So talking about cars, we do have a question from Ian, and I'm not sure you guys are going to be able to answer this. Maybe you can give your opinion on it instead. But he says, do you have any plans to release any more 132nd rally cars similar to the Ford Fiesta you've done in the past? Bearing in mind some of the development work has already been you've done for your electric new Puma.
No, it's a great question. For some reason, I don't do a lot of the choosing, but it hasn't been something that we've got lined up currently in the next few years. Is that sort of, I mean, I can say next few years because everything takes a few years to do. Been looking at some little cars for our starter set range. The kind of new set of really simple kits are coming out aimed at the kind of beginner market, but also trying to create, I guess they are specifically made for the beginners, but I think some of the stuff that's coming out, and they're actually a wonderful little simple kits for experienced modelers to have a break from their complicated stuff. It's interesting that the using some of the Scalextric data, it is useful, and there's definitely some information there. But there's also sometimes that have had to like slightly tweak something to fit the kind of the chassis that is the same for every car, but rarely. Like often it fits really quite well. But it's definitely, it's an interesting question. And we do, like, if we're looking at cars, we'd look to see how much data we can share. Sometimes we actually do share stuff between Airfix and Corgi a little bit more, because they're also a company.
We've done it on Quick Build because the split screen camper in Quick Build is a good example, because with the surface data was provided by VW, wasn't it, for the 30-second scale in Scalextrics, and when we took it up scale almost to 24th, 25th scale for the camper, we found an anomaly in the roof scale, the actual rear of the roof. Well, that was it was VW CAD. It wasn't right. At that size it was an issue. As soon as we took it this size, it became a problem. And if you look at the Revell I've got to say, competitor products on the 16th, the inaccuracy in the roof is still there because again, but it's something that we corrected for quick build, and we then pass that data back to VW, and I believe it's now in their update of the CAD. It's correct. But, so there's things that we find, but I think again, it's the subject matter. Again, it's we've all got where we want, what we want. We've all got preferences to what we like, and I know, from my point of view, there's a huge heap of products that I would like to see happen. What is quite exciting again is I think, because we are in an age of CAD now, what CAD is bringing to models, it's bringing the level of accuracy. The work that Chris and the team do there is just astonishing. The amount of information that you can actually put in. I grabbed it jokingly earlier, but it's like if you look at that 24th sprue there, that is of the ME109. If you look at the components that are in it, yes, they are nice components, and yes, they are of their time. But if you look at the fuselage there, there's a whole world of difference. First of all, is the thickness, and if you look at, if you take that there, so if you look at let's try and hold it up for the camera. Let's try and get that in the front of the camera. If you look at the thickness here of this material, that's actually, it's a weight. You can feel it. It's heavy. It's a weighty. It's a weighty product. You take the new two fuselage halves. Yes, it hasn't got the mass of material in there, and the thicknesses. Yes, they're not representative in actual real manufacturing thicknesses, but obviously, it's significantly different. The level of detail, the level of accuracy that's gone into it, and this is purely because of CAD. This is because the level of data that we can retrieve and modern manufacturing CNC programming. So we can actually take, and this is the relation between the CAD and the CAM, that we can actually take the data that Chris has created and transfer that directly into machining. So whether it be for a CNC for a milling machine cutting it, whether it be for EDM, and the level of detail in the electrodes. The electrodes themselves, the wing electrodes, they're a work of art. You almost want to frame them and put them on the wall. These are a byproduct of the manufacturing, but they are so exciting to see, and that's why. From a quality point of view, from a care point of view, even how we clean the molds. If you scratch that mold, you will get that scratch on that part. And it's simple as that. So we're so careful. And if you get a part stuck in the mold, so if you've got molding that breaks off, and I'll give you an example. There's one of the Spitfire wheels. It wants the grip on the wrong half. Again, Chris's draft issues. He's pleased his draft right one a bit. It wants the grip on the wrong half. So in having to retrieve that from the mold, we have to be so careful that we don't damage the mold or throw an edge or scratch it, because that will come out on the next molding. So whatever is on that surface, we'll see there, it's passed on.
So a question here from you'll love this, Canigram from Mongo. He says hi to us all, obviously, and everyone in the chat. But his question is, what's been the biggest technological change in injection molding over the last 10 years or so?
Well, there's been lots of changes. The process inherently remains the same. What we have got, though, is we've got, give you a good example, on the machine that you might have seen in some videos, we've got a lot more control on the process. So when we're putting a mold into a machine, the machine that we're putting these tools into, we've got a high level of accuracy. So give an example with, I'm not trying to talk out a term for anything that's done offshore, is the machine that we put it into it's a brand new piece of tooling and a brand new piece of machinery. So yes, it's like making a cake. You'll very rarely make the same cake twice, but you have a set of ingredients. And what's happening is our machines are a microprocessor controlled. So for example, if we're demanding a certain speed, a certain pressure, a certain temperature, the machine it's a new machine, it's calibrated. And the level of accuracy that we can hold, and we can find that just a few degrees in processing temperature can make a difference. And a good example of that is if you leave the material sat in the barrel of the machine. So when you turn the machine on in the morning, the machine warms up. The material that's in the barrel, if you leave it in there too long, can become contaminated. It can actually start to degrade it, start to burn the material. And if you say, for argument's sake, that's 136 grams shot weight. So if you've got a barrel that can take 1.5 kilos, it's the material that's coming in this end before it injects into a part. It's gone through 15 cycles. If it's a minute cycle, it's been there 15 minutes. So there's a lot of accuracy. There's a lot of things that can go wrong within the molding process. But the biggest technical advance for us in the last thing is microprocessor control. So what we can do now is we can actually almost quality control on the machine. So we can get a good set of mouldings out, and we know that it was a certain cycle time, it was a certain fill pressure, it was a certain speed, we had a certain temperature. So we can close loop that now. We can say, right, those are our processing conditions. So we can lock that down. We can hold that parameter. So if we can, repeat that, what we should get is the same moulding every time. So if we're getting the right pack pressure on there, okay, there's variables in there, ambient temperature, water temperature, there's all these factors. But for us, it's having the control on the process, having the kit that can deliver a consistent moulding, because we're not just making one sprue a day, we're making thousands, and it's a repeatable process. So for us, that's the biggest advance in the injection moulding side. The next biggest advance is obviously the tooling, is the materials in tooling. And it's evolving the whole time. And I'm sure Chris would agree. If we made the Spitfire again, there's things we do differently. There's things that they'd probably change from a design point of view. There's things that we would change from a tooling point of view. But all you're trying to do is put in the best learnt knowledge into it, and every one you make is a prototype. There's no, they're not off the shelf, these tools, and no one's made a 124 Spitfire the same way before. So everything you do is a learning curve, and you can put into it all the right ingredients, and you'll get 9.9 out of 10 if you're lucky.
Yeah.
How about yourself, Chris? I mean, obviously, same sort of question to you, really.
It was certainly, this is in terms of tooling, it's definitely obviously Mark's area of expertise rather than mine. I'm just learning as we go along all the time. But I guess the thing for us is it's sort of about the EDM process and being able to get the kind of finer details, the thing that's I guess more directly related to our part of it, being more confident to put on those kind of finer rivets and it come out okay and to scale and not oversized. It's a funny one because we've like sort of gone into this. I guess all of us really as the CAD designers, we aren't tool makers, and that isn't the thing that we studied. We obviously did study something to do with injection molding and have to have an understanding of the process. But the main thing I think I learned about the process was that it's like a dark art. Like there is an artistry to it rather than just a technical knowledge, because of the complications of fluid dynamics and such high pressures. You can't be absolutely like Mark's saying that you kind of know how it should work. But when you do it, sometimes it doesn't quite work out how you think it should work, and so then you need to do some little tweaks. There is a real learnt craft in making tools and making tools work well, that comes from experience and knowledge, and that obviously that isn't the same room that we're sitting in, which is thankfully much cleverer people are trying to figure that out. But we get to do the enjoy the kind of this next step of detail that we can add to it. I think is that's the direct thing that I think we get to enjoy.
I know they obviously, we were talking about Japanese, but I know some of the Japanese manufacturers will actually make a development tool for a kit to learn how it's going to mold, how it's going to behave before they come back and make a tool effectively to deliver that best product. So obviously again a different marketplace. If you're making a 1/24 scale car, yes, you're going to sell 500,000 to 1 million kits just in the Japanese marketplace probably. So the level of investment that goes into that allows them to make effectively, let's build one, a prototype, let's test it, let's learn from that, and then obviously we'll tool it. But Chris obviously, I think Chris is quite modest in what he says there in his abilities, because the way it's modelled, the way that we get the data, the way that we're able to work with that, and again, modern CNC does allow you to achieve a lot more. And obviously we've seen that for many years, obviously with the Japanese kit marketplace, like I've said again, and the work that goes into it. It's an art form, and molding is a bit of a black art, and sometimes things that should work don't work, things that should never even be on the same page all of a sudden give you a result, and you think, well, how does that
that's
work?
engineering, right? I can think of a 1,000 different examples of things that should never ever work, but they do.
Right.
But someone's taken the courage to do it. Okay, what I'm going to do, I'm a little conscious of the fact that we are over an hour already. It's been such a fascinating conversation that I could go on forever, but I'm just going to fire a couple of quick fire questions at you, Mark mainly. Just to let you know, those that are watching, obviously Chris has jumped in for us this afternoon because Luke, the researcher, is not feeling very well. So a big thank you to Chris. But we will be grabbing Luke at some point when he's feeling a little bit better and put him under the cosh, so to speak. So that'll be coming up at some point. We've got to arrange it yet, but bear with me for that. So any questions that were asked in relation to research or possible things coming, I will note those down. We'll visit that at some point. But in relation to yourself, Mark, something which I really wanted to get across within our conversation on something that's been very exciting and very much spoken about with this particular kit is the recycling element of the product, and not just the product we get, but also how you do things in that factory. Because one of the things I was absolutely amazed was the attitude of zero waste. Maybe you can give me a couple of minutes explanation of what your business does to do that and what the end product can achieve for that recycling stroke carbon neutral sort of approach.
Well, I think obviously we've all seen a swing change and the way plastics are viewed, not just obviously in this marketplace, but across all marketplaces. Now, for me, plastics gets bad press, but it's a general bad press. And for me, plastic is a very sustainable material, because if it's managed and used correctly, it's one of the most sustainable materials. It's like we've all learned to do with cars. We can take a car, we can cut a car up, we can recycle it. We can turn it into a piece for an aeroplane or a bit for a ship, or something that is used in many different applications. And with the right plastics, it can be used again. Now, this material is a polystyrene. It's a styrenic, and it can be used multiple times. Now, the material that we're actually based it upon, as like I mentioned earlier, it's a material that's from 1985. The formulation. Now, this material is oil based, and it is obviously a mineral oil base that's extruded obviously from a petroleum oil manufacturer basis. I'm not a polymer scientist, but I'll give you a little bit of background. I was having an interesting conversation the other day that not on this particular product, but in theory on this product, we can actually manufacture not a carbon neutral, but a carbon negative product. So you can actually have kits that are carbon negative, because you can actually use the main ingredient in plastics now is a monomer. Now, that monomer can be sourced from oil. It can be sourced from a plant-based oil. So if you take something like rapeseed oil, for example, it's grown rapeseed, so therefore it's carbon neutral. So it's already absorbed CO2 in the growth of the plant where the oil comes from. You can then now buy that monomer and have that used as your additive, as a base into your polymer. So you can actually produce that material. So you're working with a carbon negative degree, obviously, and a high degree of the polymer is made obviously of the monomer. So from that point of view, yes, that is a very big positive. But what we're also aiming for is we're aiming for zero landfill. So on the sprue, as we mould them, as I'll show you here. So for example, we will actually mould like that. These are the sprues that you will see. So we'll break those off, and we will actually retrieve. This is called the runner. This is the bit that actually feeds into your frames. We will take that, we will regrind that, and obviously you saw that happening obviously on site, James. That is actually put back in as a small percentage additive. Now, typically 5 to 10%. If we start to go more than that, then potentially we can have issues and have problems with it. So yeah, there is a material in this that allows us to actually this can be used a number of times. So once we've actually got this material, we can break it down, we can grind it, we can re-chip it, and we can put that back in. So yes, we're registered with as most manufacturers are now. We're registered with an organisation called EcoVadis, and what that does is become almost more important now to our customer base than say like ISO 9000 was. Like it's less of an importance to have a quality accreditation. It's more important now to have an environmental policy and an environmental statement. So what we try and do is we try and be very sensible in what we source. Now, as I said, when you visited, the instruction leaflets, they're printed by a local company. The boxes are done locally. So within a 25-mile radius, 90% of the product, is produced. Okay, we can't actually produce the raw plastic, and the decal sheets are coming from our friends in Italy. They're coming from Cartograph, but again, they have an environmental policy. So it's a consideration, and you will note in the kit when you actually open the kit, there's a couple of pieces of brown paper in there, purely to save on the amount of plastic packaging that we are there. And again, potentially in the future, we can look at offset on the plastic bags. You know, we did talk, could we get away with a paper bag on the kit? You know, could we actually just go pure paper? Could we say all plastic? You know, it seems crazy. We've got a plastic kit, but we're trying to take the plastic bags out because they're
it's not crazy. It's not crazy. I mean, it was one thing in which, on the visit that I was lucky enough to go on to your factory, it was the one thing that I thought, wow, that just really is wonderful. And the the funny part was, I've looked in the new kit literally only the other day, and I can't explain the excitement of peeling back paper rather than plastic. It makes no sense, but it's almost like unwrapping a box within a box within a box. It's like Christmas. It literally
it's that brown paper. It's that, you know, that brown paper parcel we used to get, you know, 20, 30 years ago. You know, what's the most exciting thing? Oh, it's in the brown paper. And even down to the paper, that is recycled paper. That was we worked with a company called Challenge Packaging. We set them a task. What is the most, you know, recycled way that we can produce? The base, the white box base, is made. The internal parts of it are made from reprocessed materials. And again, down to the Airfix embossed stamps on the bottom. That's a bit of free detail there. But all the way along, we've tried to look at what's possible, what can we achieve, what can we do here? And yes, these have you might notice some of the sprues. I think all the sprues have got somewhere got the recycling logo on them. And again, the sprues, you know, I cut mine up. We use them for little paint dips, don't we? We know that, but there's no reason why that could not be put into your household recycling. And if it's identifiable, and I think this is something that we've all got to be aware of, like in single-use plastics. It's not so much we're able at this end to identify it, it's how is the end handler, you know, we were disposing, can they actually hand it to them, understand the product, can it be repurposed, can it be reprocessed? And I'm not saying for any way, shape or form we want to start grinding up, you know, new kits when we bought them, but you know, it's not designed to be a throwaway item. It's something that's going to give you years of pleasure, you know, hopefully not making, you know, it's a few months pleasure, but you know, you'll have it on display, you know. And I've got, you know, dotted around my office like I showed you earlier. I've got various kits that I've made from the 70s. You know, I've still in my office that, you know, I take a lot of pleasure from, and you know, so the hobby can be sustainable, and as you know, as we move forward, the use of plant-based monomers. Yes, it's extra money. It costs more. You know, for example, it's £1,200 a ton. Now you can get a lot of Airfix kits out at £1,200 per ton, but potentially what we could offer Airfix, and you know, we're almost there, is a carbon neutral or a carbon offset product. So in the box there, you can have a product that is carbon neutral, potentially, you know, carbon negative, actually in the raw plastic, which is quite exciting for us as a manufacturer.
It's something in which I was quite amazed at myself. So thank you for that. I just noticed, Chris, your comment, so that's fine. Basically, I mean, we've been running for longer than I anticipated anyway. So I'm going to start wrapping it up, really, to be honest. Very, very quickly. I don't want to ignore Moss because he's, you know, he'll batter me later if I don't. So. We all know Moss. He's got a question. Slide molding has been branded as the holy grail of top modeling tools. Is it something that you'd look to expand to use in the future?
Yeah, that's a good question. It's something that we often chat about, and we have used it a few times. We've got a slide in this Spitfire to get some of the detail on the sort of top of the what would be over the top of where the oil is in the Spitfire, on the fuselage parts. The challenge I think we have, just at this sort of budgets that we're running at, is it makes the tool cost a lot more, and it is an extra thing to go wrong. I don't know how frequently, and Mark can probably say maybe it's fine, but I think we've perhaps in the past had some challenges of it going wrong.
I think the issue comes from is, you know, tooling costs works better if it can do that. If you can open and close, if you can open and that lifts out in one direction, generally it's a more economical way of doing it. As soon as you start having that, then that, or that in the process of that, it adds cost to it. Now, moving parts within a tool, so yes, opening and closing is fine. Moving parts to lots of products we manufacture require slides and side actions to to achieve this. But it's, if I throw it out there, give an example, one slide, I don't know, £1,000, £1,500 in a tool. So if you've got a tool that requires 4 or 5 of them, depending, because the problem is if you imagine like a commercial product. So if you've got, I don't know, a piece, say you're making a tool with 6 pipes. So six pipe joiners that work in this direction. You can have one slide that pulls out, and you can run 6 in a line. So you can do multiple jobs with it. The problem that we have with these, because most of the parts are unique or making 1 or 2 parts of it, is you're actually adding a slide to do one job. So like Chris has already said on the fuselage there, yeah, it's got one part. A very complex slide that you probably picked up on is the cockpit canopy. That's a really nice piece of tooling. You get 2 cockpits with the kit. You've got one that's got the bulge in it that creates an undercut. Now the way to achieve that is effectively it's a wedge. That wedge has to drop back to allow the sides to come in to pass through. If you're passing steel through a shape that's smaller than the aperture it's created, you've got to collapse it somehow. That's a very complicated little slide. It's a very clever piece of tooling. You do end up with a witness line through the cockpit, which has to be polished out. That's why in the kit you get 2. You get one that is, that doesn't have the line in it, that's effectively the sides are parallel. You get one with the undercut. Again, it's a slide. So yes, it's added considerable cost within the tooling to achieve that. And in an ideal world, Chris was probably better off talking about this than me, but like the radiator box, Chris, isn't it? Potentially that's made up of several parts purely to avoid making slides and side actions.
Yeah, absolutely. There's always that chat, and I think we as designers would love to use slides a lot more because it makes the life a bit easier, to be honest, as you can probably imagine, and it can also make the building process that little bit nicer as well. And I guess it's something that I think we will continue to use them, but we're just always trying to balance it against the money, and so if we start making more money, then we'll start using more slides.
Yeah, possibly. Indeed.
But we want to try and use them as intelligently as we can. And where something, and you're kind of balancing what's the how will this be like really negatively affected by not using it? Like will this part be just overly complicated and messy to put together? But if we use it, will it be like much better experience? And if that balance is enough, then we would probably use a slide. But obviously some manufacturers are using loads, and that's brilliant. But unfortunately, we haven't yet felt like we can make it commercially viable to do it a lot. But certainly something we always think about.
If you look at the quick build product, there's lots of slides in quick build products because it's a much higher volume. You give you an example. If you take something like our Lamborghini or McLaren, it's run several 100,000 units. So in terms of the value that it adds to the tooling, yes, it actually saves time in the manufacturing process by actually having the slides there. But the commercial offset, determines that it warrants that extra level of investment on a kit of this type, where yes, it would be sold in the hopefully tens of thousands, but it's where's that money best spent? Where is that level of investment put? Best put into the tooling. But I think
that's great.
Sometimes it's a necessary. Certainly in that cockpit canopy. Yeah, it's been an expensive piece of tooling, but it warrants it.
It was like that was the only way to do that as well. To get that sort of bulge canopy, we couldn't have done a canopy in 2 halves like that. That just wasn't going to be an option. And so if you wanted to have it and we had to represent it accurately. So actually for that part there was a no-brainer. It's like that was the only option for us. So
that's quite an interesting.
Occasionally that happens.
That's pre-polishing. There we are. So just to show you there, that's one of the tests. That's one of the first test canopies that was produced in China, and you can see that's just we're learning there. See that big line there? That's the flow line, the weld line, and you can see there that's where the material was knitting. So this is before it's actually polished. So again, we had this to evaluate this and decide what we were going to do with it before we actually finish the tool.
So, guys, thank you so much for your interaction this afternoon. I do have a message from Dal for our viewers. Just bear with me 1 second.
Don't forget, if you're an Airfix Club member, you can donate your flying hours to Models for Heroes.
Can't use that enough. So I'm going to wrap up now. Chris, I know you've got to shoot off. Thank you so much for stepping in. I really appreciate it. Mark, fascinating as always to have a chat with you. and everyone that's taken the time to watch. There has been only small numbers, and I fully appreciate that for the time of day that we went live. But if you're watching this back, make sure you subscribe, make sure you like the video, and make sure you make a comment, because any question you ask, I can always throw it back over to these guys at some point. Like I say, we're going to get Luke the researcher in. We may even get Dale in as well, put him through the grind. And some other invites have gone out to all sorts of places. So please stay tuned for what's going to come up next. But from us lot to you lot, thank you very much for watching. That is us. Any last comments you want to make, guys? By all means do.
No, it's been great. Thanks. Thoroughly enjoyed jumping in last minute. It's a really nice chat with you two guys.
Thanks for stepping in, Chris. But no, just obviously thanks, and you know, just pleased that you guys are taking interest in what we do. Hopefully, it's given you guys an appreciation. Obviously, I know as a model maker myself, you know, you would think, why have they done it like that? Why is this? I think obviously the more that we can get across to you guys, you'll realise that sometimes there is method in our madness, and yeah, there is a, you know, it's always a fine line between what's viable commercially and what's achievable technically, and hopefully that will come across.
Wonderful. Okay, well, now for those wonderful titles, and thank you very much, everyone. We'll see you soon. Bye-bye for now.